Recording in progress.
Okay, guys. Good evening, all. Everyone can hear me. Online students, is my voice is loud and clear? Online students, yes, it is clear, right? Done. So let's start the session. In the last class, we are discussing about the simple linear regression coding part, and I have shown you how to do the coding part of a simple linear regression, where we have implemented all the 6 steps. So let's see once again this one. And first, let us understand the CRISP-DM methodology. The first step is business problem understanding. First, we have to understand the business problem and what is the requirement. Second, we have to color the data and we have to understand each and every variable in that, whatever the variables are there, each and every input variable and the output variable. Next, we have to do the data pre-processing. The data pre-processing includes data cleaning, data wrangling, and EDA with train test split. So these are the things which includes data cleaning and data wrangling, EDA, and train test split. This all comes under data pre-processing. Next, we are going to do the fourth step called as modeling. In the modeling, we are going to build a model. We are going to build a model by using any algorithm. By using ML algorithm, we are going to build the model. By using ML means ML, AM is A, whatever the algorithm. We are going to build the model by using the algorithm. Next, we are going to evaluation and model selection. Evaluation and model selection. And finally, whatever we are having, we are going to presentation. So this is the CRISP-DM methodology. So CRISP-DM methodology involves business problem understanding, data pre-processing, modeling, evaluation, and presentation. So in the previous classes, okay, from the day one on the Python, whatever we have discussed till now, that is initially first we have completed the core Python. After completing the core Python, we have moved towards the Python for data science. That is NumPy, Pandas, Matplotlib, and Seaborn. Followed by we have done the statistics. Within the statistics, we have done the descriptive statistics. First, we have done the descriptive statistics, followed by inferential statistics, then followed by EDA. That using the Seaborn, we have done the EDA by plotting the multiple. And next, we have done the data cleaning. In the data cleaning, we have done how to treat the missing values and how to treat the outliers, all these things, right? Next, followed by data wrangling. Once we have completed the basic part up to here, okay, once we have completed, basically, this is called as prerequisite of the data science. This part is called as prerequisite of any data scientist for doing the data science course generally. Apart from Naresh IT, it is generally data science. Anyone wants to learn means they should be good at the Python and stats already. Then they'll start directly from here, EDA, data cleaning, or data wrangling. So these three parts is called as data pre-processing. These three only is called as data pre-processing, right? After this, we are going to apply the modeling. Now let us see what is meant by modeling And these two steps, let us focus now these two steps. Earlier, we have focused on EDA, data cleaning, data wrangling. These three of them we are going to do irrespective of algorithm, whether the algorithm is linear regression, whether the algorithm is non-linear regression, whether the algorithm is KNN, or whether the algorithm is lasso, whatever the algorithm it is. Irrespective of algorithm, we are going to do this one till here. It is not dependent on algorithm. Data pre-processing, most important point in the notes we have to write is data pre-processing is not dependent on which algorithm we are using, is not dependent on which algorithm we are using. The entire data pre-processing is not dependent on which algorithm we are going to use. Whether it is a linear regression, also the data pre-processing remains same. The same technique of data cleaning we have to apply. The same technique of outliers we have to apply. The same technique of the skewed distribution has to be converted to normal distribution. If you have to do encoding, the same encoding has to be done. There is no dependency. Data pre-processing is not dependent on which algorithm we are going to use. Okay, which algorithm we are going to use, it is not going to be dependent on that. Irrespective, we have to do. Irrespective, we have to do. Okay, so for linear regression, do we have to do like this? Or for lasso regression, we have to do like this. No need to ask any question. Irrespective of any algorithm, data pre-processing, never it will be dependent. Okay, never it will be dependent. Only for certain algorithm, scaling is dependent. In the scaling, min-max scalar, standard scalar is there. That only is dependency. Okay, nothing else is having anything. Right? Now, coming to the so data pre-processing is everything is common for every algorithm. Now, coming to the most important, modeling. Means when we are going to do the modeling after train test split. First, after train test split. After train test split, we apply modeling. After data pre-processing, with that data pre-processing is completed. Now we are going to apply the modeling. Now let us start with the modeling. Now in the modeling, what we are going to do? Now first, what we are going to do in the modeling, that is secondary. First, what is meant by modeling? First, understand what is meant by modeling. Modeling means the machine learns the data as per algorithm. It learns the data as per the algorithm. Means, what is the meaning of that? For example, you are the students and I'm going to share you the notes. You guys are going to learn as whatever the notes I have shared to you. In that, whatever the notes PPT is there, you are going to read one by one. Page number one, first page, followed by second page, followed by third page. For example, if I say that machine learning was very easily written in this particular website, in that particular blog, it is very easily. Please go through this website. If I give any suggestion like that, obviously you'll go to that one. If I say that follow this textbook, this will be very easy when compared to any other books, automatically you'll read that one. Means you are following as per the instructions of the trainer, whatever he is instructing to you, and you are following that one. Similarly, machine also will learn the data as per the algorithm. In every algorithm, the procedure of learning is different. Algorithm means nothing but procedure. Procedure of learning the data. So in KNN, one way of procedure is there. In logistic regression, one way of procedure is there. In lasso regression, one way of procedure is there. These are all the procedures. For example, I'm asking you to read the ML. Okay, I ask you to read the data science course. Whatever the data science course we are having, please read this and please understand the course and learn everything. I have told like this. So what is the procedure you are going to follow? That is your choice. Some people will learn at night, then some people will start reading at night 10 o'clock. Some people will start reading at morning 4 o'clock. Some people will learn at 10 o'clock. Some people will not even read. Directly they'll sit in the class. That is their choice. As per their requirement, they are doing. What is the ultimate goal of anyone? Whatever the procedure they are following, whatever the textbook they are following, whichever the page number they are following, that is completely their choice. For example, one person is there, he'll open one particular textbook and he will directly open to the chapter. Whatever the chapter, tomorrow's exam is there, directly he will open that chapter. One person is there, he'll open the page number 1 only. Instead of going with the chapters, he'll go with the page number 1 followed by in the sequential order. Though it takes time also in the sequential order. Okay, different persons are going to learn in a different way. What is the ultimate goal of everyone? To get the maximum marks in the subject. The ultimate goal is maximum marks in the subject. As a students, the error should be low. Whether you, whatever the procedure you follow also, final ultimate goal is to get the maximum marks. I want maximum marks. It is not compulsory that after this class, you have to compulsory go to the lab only. You have to sit for at least 1 hour. There is no rule like that. Follow whatever the procedure you want. Follow whatever the things you want. But ultimate thing is, I want the maximum marks. Okay. This is as per the student. Similarly, machine also same. In the machine learning also, do whatever the algorithm you want. My ultimate goal is give me the maximum accuracy. Apply whatever the algorithm you want. Apply this one, apply that one. Don't tell this. Search. No, now, after the class, sir, should I follow this book? You'll ask. What should I say? Answer. Should I follow this book or not? You'll ask me the question. What should I say? The answer. You'll say that, sir, should I go with respect to this particular website or not? Should I see the notes in this particular website or not? Sir, one of my friend has shared me these notes. Should I follow this one or not? Whatever you want, you follow. Finally, the thing is whether you're understanding or not, that is important. If you're understanding is follow. What's wrong in that? If you're not able to understand, you are getting confused. Ignore that one. Remove that one. Why you're following and why you're getting confused of yourself? Whichever the things you follow, whichever the things you learn, whichever the textbook you learn, finally the ultimate goal is we want the maximum marks. There is no rule that you have to follow in this book only. Hey, other student has shared that. No, don't follow. That is their institute material. You don't follow here. That material you have to follow in that institute only. Nothing like that. Whatever the institute material, whatever the material is there, what's the problem? For example, some XYZ trainer is explaining the YouTube. Should we follow or not, miss? If you're understanding, follow. Click on the subscribe and follow him. If you're not able to understand, don't follow. What is the ultimate goal? If you follow or not follow, what is the ultimate goal? Finally, you have to learn the subject. Learning the subject is important. No, you have to sit in my class only. You should not follow any YouTube channel. You should not follow any textbooks. You have to follow only my material. If you don't understand also, not a problem, but you have to follow my material. This is not like that. Our ultimate goal is to get with respect to maximum marks. What are the things we want, we can follow. Right? Similarly, here also the same machine. In the machine, they'll ask us in the data science project, they'll ask us, I want the maximum accuracy. For getting the maximum accuracy, which procedure we have to follow, miss? As per your choice. Which algorithm we have to do, miss? As per your choice. The only thing is, in the entire data, 95% of the data you have to consider. You can't remove more than 5% of the data as per your choice. Statistically, you can remove. Sir, I'm removing this particular column. Why? What is the reason? I'm not interested, sir, to keep that one. You can't say like that. You have to statistically prove that this particular variable is not useful, either by using correlation coefficient or variance or something. Statistically, you have to prove. Statistically, if you prove, you can delete whatever the data you want. Simply as per your choice, you can't delete the data. Okay, finally, the ultimate goal of any data science project is to get the maximum accuracy. We have to get the maximum accuracy. This is the ultimate goal. Okay, whether in whatever the procedure you are following, this is the ultimate goal, right? So we, in order to get this one, so first we are going to try with the algorithm one. Means first we will try this procedure. If this procedure is getting successful, means we'll continue with that one. If this procedure is not getting success, our requirement it is not satisfying, then what we'll do? For example, I have taken one material, Amma. In this material, I have learned the things. And after that, I have seen the interview questions for the data science in the Google. And new questions are there, which in this material, the answers are not available. Then what I have to do? I will read one more material, right? In this material also, everything is not there. Then what I will do? I will read one more material. I will read one more. Till I get the complete knowledge, I will read the materials, multiple materials I will read. Which material, in which material, which answer is there? Who knows? Without saying that, without opening the material, without opening the page number, without seeing the pages, how you can say by seeing the heading of the page number, by seeing the textbook heading itself, can you decide the inside the what would be the content? By seeing the title name, Python for data science is the content. Means everything will be there. Huh? Python for data science means everything will be there. Python for machine learning means everything will be there. Or machine learning means everything will be there. So based on the title, we are not going to decide. Just we are going to open the material and we are going to learn one by one. Similarly, here also the same. By seeing the data, we are not going to say that which algorithm will be the best. Which procedure is going to give the best accuracy. By seeing the data, none of them can predict like that. None of them can say. So then what we have to do is each algorithm we have to apply. Apply each and every algorithm on the given data. On the same data, we have to apply multiple algorithms. On the same data, apply various ML algorithms and identify which gives the best accuracy. Which algorithm gives the best accuracy, that we are going to finalize. Okay, we have to apply all the algorithms one by one, one after one. Okay, so in the modeling, what I'm going to do means first I'm going to apply first algorithm and I will evaluate. With that, first algorithm will be completed. Next, I will go to the second algorithm. Again, I will do the modeling. Again, I will evaluate. Completed. Third algorithm, modeling, evaluation, completed. Fourth algorithm, modeling, evaluation, completed. Fifth algorithm, modeling, evaluation, completed. Sixth algorithm, modeling, evaluation. For every algorithm, modeling and evaluation only. Data pre-processing is not going to change. It is fixed. It is fixed. Only the changes starts only with the modeling and evaluation. So first I'm going to apply the ML algorithm 1. How to apply? Means for modeling means it is going to learn the data. What data? What are the data you provided? Trained data. It will learn the trained data. It will try to understand the trained data as per the algorithm wise. Means in the modeling, common steps. What is the common steps we are going to do? Means first import ML algorithm. First, we are going to import ML algorithm. Whatever we have imported algorithm, that we are going to save in a model name, some model. M is equal to that algorithm. And with this M dot fit on X train, Y train. Now, means with this, it is going to understand the train data. So here, it is going to understand this train data based on this algorithm. If the algorithm changes, understanding changes. Instead of SRK, if another trainer is there in my position, he will explain in a different way, right? But linear regression only. Linear regression only, but he will try to explain in a different way. Every trainer will explain in a different ways. But everyone is ultimately, finally, they are going to explain linear regression only. But in a different way, they are going to explain. Now, which trainer is best one, miss? After listening to all the trainers, we can conclude that, okay, he has explained very clearly, step by step. Then we can conclude. Is it clear? Similarly, here also the same. First, we are going to import the ML algorithm, and that algorithm we are going to fit on the X train, Y train. Now it will learn the data as per the algorithm wise. Whatever the algorithm you are using here, fit this algorithm wise, it is going to learn. Linear regression means it will identify linear regression between them. If you give non-linear means it will identify the non-linear regression between them. If you give lasso means it will identify the lasso regression between them. Whatever the regression, whatever the algorithm you are trying to fit, it will identify. Once this is done, modeling is completed. Now I want to evaluate my model. I want to evaluate the model. Next one is evaluation. I want to evaluate my model, whether my model is a good one or a bad one. For everything, it is same. For everything, it is same. My model is a good or a bad one. Means for regression algorithms, we are going to calculate the RMSE. So evaluation, we are going to do on a test data. Then how we have to do the test data means calculate the RMSE. Evaluation means basically calculate the RMSE or R square, any one. One is accuracy wise, one is error wise. Calculate the RMSE or R square on the test data. Calculate the RMSE or R square on the test data. How to calculate RMSE means RMSE of original data, test data, this is the original, and predicted Y. Between the original Y versus predicted Y versus Y hat. This between RMSE of Y versus Y hat. So that is nothing but between Y test versus Y pred test. Now the question is Y test means, okay, this we have got during the train test split. From where we will get the Y pred test then? So in order to get the Y pred test, first we have to do the model. Whatever the model is there, model dot predict on X test. We have to predict on X test, and whatever the values we have got, these values are called as Y pred test. Right? For any data set, it is common. For any algorithm, this is common. Whatever I'm writing, everything, it is common for all the regression algorithms. Regression algorithms, for everything, it is common. Once we have done the evaluation, now we have identified whether our model is a good one or a bad one. Whether we have to select whether our model is a good one or a bad one. That is called as model selection. How we are going to decide our model is a good one or a bad one means, one, compare between train and test. Train accuracy and test accuracy. In the class, how the performance, and after the class, how is the performance. Compare between them. Two, as the data changes, how the performance changes, that is CV. This is the two. And the third one is whether it satisfies the business problem. It satisfies business problem. These are the three things which we have to see. 1, 2, and 3. First one is compare between the train and test. Second one is cross validation score. Third one is compare between the whether it satisfies the business problem. 4, it satisfies the assumptions if it is linear regression. Only for linear regression, this one additionally. If you are applying a linear regression, the fourth one will come into picture. Otherwise, this is not there. For none of the algorithms, not with this completed. Only for linear regression. Only for linear regression, we are having this one. Only for linear regression, we have to check this one. So for every algorithm, we are going to do the same. Okay. And from this, finally, once we have completed this one, from this, finally, we are going to conclude. Finally, we are going to conclude whether this ML algorithm, whether ML algorithm is good or bad for the given data. For the given data, whether it is a good or a bad model, whether it is a good one or a bad one for the given data. This is the one which we are going to do. In this way, we are going to conclude for every algorithm. First, we'll try algorithm number 1, completed. Go with the algorithm number 2, same to same, completed. Algorithm number 3, completed. Algorithm number 4, completed. Algorithm number 5, completed. Whatever the algorithms are related to the given project, we have to apply all the things. If you are having 20 algorithms for the given data applicable means, we have to try with 20. 30 means 30, 40 means 40, 900 means 900. Example. We'll have only maximum 10. Whatever the 10 algorithms are there, every algorithm we have to apply. We have to cross check whether which algorithm is the finally the best one. Is that clear, guys? Finally, from this, we are concluding this one. This is the final conclusion. Now, once this is completed for each and every algorithm, this is completed. Finally, identify which is best from all good models. From all the good models, identify the best one. Good is different, best is different. Okay, in this class, whoever has crossed more than 90%, they are good students. Okay, according to me. Whoever has crossed the score more than or equal to 90, they are good students. Assume one student has got 92. One student has got 94. One student has got 96. One student has got 93. And one more student has got 92. Like this, 10 students has got between 90 to 100. 10 students are there. Out of these 10 students, 10 of them are good only. Out of these, 10 of them are good only. But within the 10 good students, who is the best one, miss? Who got the maximum? Out of these 10, who got the maximum? He is the best. Similarly, here also the same. Out of all the good models, which is the best, miss? Within the good models, identify which is the top accuracy. That is the final one, and that we have to share it to the client. Is that clear, guys? If it is clear, write in the notes, and for everything, we are going to apply the same logic. Yes, CV should be compared with the test. Compare between the train and test. Train accuracy and test accuracy should be the same. First one is train is equal to test. Second one, CV should be equal to your test. And at the same time, it satisfies the test accuracy. Whatever the test is there, test accuracy should satisfy the business problem. Test we have to compare with everything. Test data we have to test accuracy. Whatever the test accuracy we have got here, whether it is a RMSE or whether it is a R square, whether it is a accuracy, whatever it is, whatever we have got here, this one should be compared. And then only we can conclude whether it is a good one or a bad one. Is that clear, guys? So once this is clear, let us see one by one, step by step. For all the data sets, I'm going to follow the same procedure, guys. For all the projects, entire projects of ML, the concept remains same. For entire concepts, it is going to remain same. First, modeling, evaluation, whether it is a good model or a bad model, conclude. Modeling, evaluation, whether it is a good model or a bad model, conclude. Modeling, evaluation, whether it is a good or bad. And once all the models are completed, identify the best. Okay. These three things are fixed for the fixed data. Data should be fixed. Data should not change. Data should not change. It should be fixed. So data should be fixed means some random state we have to fix and the data should be locked. The data should not change every time. Done? Done, guys? So let's do this one by one. So your voice, Satish says that voice is not clear. Others, it is clear, right? Others, it is clear. Yes. Done. Yeah, Satish, can you please relog in if it is not clear? Others confirms that it is clear. Manikanta also says, guys, from my end, okay, it is clear for you also now. Okay, done. So here I'm having the data set and I have done the data cleaning, data wrangling, everything. See, up to train test split. This is the train test split which I have done. After doing the train test split, once the train test split is completed, okay, once the train test split is completed, now modeling. In the modeling, what is the first step I have told? First, you have to import. After that, save the model and fit on the X train, Y train. Right? I have told you earlier this same thing. Just in this modeling, first import the algorithm and save that algorithm in the some variable as per your choice. And that variable, whatever the variable you have fixed, that is fit on X train, Y train. This variable is called as model. This variable is called as model. Okay, it is going to save the algorithm. Model, it is going to save the algorithm, so it is called as model. So you are going to save as a model is equal to linear regression, and you are going to fit on the X train, Y train. And once this is completed, now what is the second step I have told you? Once this is done, what is the next step? This part, next m dot predict on the X test and store in the Y pred test. So I'm storing the same thing. I'm doing the same. Model dot predict on the X test and I'm going to store on the Y pred test. After prediction, what is the next step I have told here? Calculate the RMSE or R square. If the given business problem is of RMSE means we have to calculate RMSE. If the business problem is related to R square means we have to calculate the R square. Right? So how we are going to calculate the R square? The R square will be calculated. First, we are going to take the mean square error. For the mean square error, we are going to apply the square root, np dot square root on that. And R square. How to calculate R square means model dot score on the X test comma Y test. Now it is going to give the R square. Now after doing the R square, what is the next step? After doing the evaluation, what is the next step we have to do? Model selection. Model selection means compare between the train versus test, whether both of them are same or not. So the same thing I'm doing here. Model selection. I'm going to check Y pred train, that is, which is model dot predict on X train. And I'm going to check the train R square. In that model selection, what are the three things we have to do? First, we have to check whether our train accuracy is equal to test accuracy. So train accuracy, test accuracy. This is the first step. What is the second step? Whether test accuracy is equal to cross validation score. This is the second step. What is the third step? What is the third step? If test accuracy is satisfying the business problem. So these three things we have to do. First, I'm going to check checklist number 1. Checklist number 1. Check whether train accuracy, is equal, test accuracy, whether test accuracy is equal to your train accuracy. Is equal to your train accuracy. This is the check number 1 you have to do. check whether your train accuracy is equal to your test accuracy, which is also called as overfitting or underfitting. Whether your model is overfitted or underfitted means if the train accuracy is equal to test accuracy, then it is considered as a good model, or otherwise it is considered as either overfitted or underfitted. Overfitted means train accuracy will be more when compared to test accuracy. If underfitting means test accuracy will be more than the train accuracy. Is that clear? So that is with respect to whether the model is underfitted or overfitted. Next, what is the checklist number 2? Checklist number 2. What is the checklist number 2? Means we have to check whether the test accuracy is equal to cross validation score. This is the checklist number 2. So for that, I'm going to check the cross validation score. Okay. What is the checklist number 3? Whether it satisfies the business problem. Checklist 3. Check whether it satisfies the business problem requirement. This is the third one. Checklist number 3. If 3 of them satisfies, then it is a good model. If any one of them is also, it is considered as a bad model. If with this, for any other algorithms, it will be completed, but only for linear regression. Additionally, we are having checklist number 4. Checklist number 4 is additional only for the linear regression. Checklist number 4 in the bracket only for linear regression. Only for linear regression. This is applicable only for linear regression, not for anything. What is the checklist number 4 means? Check for assumptions, because this model was created based on the assumptions. So that is the reason we have to check the assumptions. This is the only algorithm we have to apply that one. The checklist number 4 is only for linear regression. For other algorithms, with this it will be completed. Clear? Got the point? If any questions are there, please ask me that. With up to here, if you are having any questions till this, that is step 1 modeling, evaluation, and model selection. Up to 3 checklist. 4th one, just ignore. Up to 3 checklist, whatever the questions you are having, please ask. 4th one we'll decide. We'll see. 4th one, we'll see. Train data, because we want to check whether our model is overfitted or underfitted. Whether it is a good model or a bad model. Sorry. Model dot. So you are saying that Wipride train I have not used anywhere, right? If I want to calculate RMSE of train data in the evaluation, you calculated only R square. Okay, you calculated based on the R square and you are comparing between the two. If you want to do the train RMSE, then test RMSE. Okay, I have got here. This is the test RMSE. Where is train RMSE? If I want to compare between the RMSEs, then I require this one. If I'm not comparing with the train and test RMSEs and I'm comparing directly with the R square, then it is not required. Still? Still, any questions? Done, guys? So for all the algorithms, same thing. For each and everything, it is same. I'm saying once again. From now, next 1 month, it is common. In the next 1 month, we are going to work on the ML only. 1 month, we are going to dedicate for ML. After that, we are going to work on the AI, followed by SQL and Tableau last. So in the next 1 month, means in the 1 month already 1 week was completed. Last week only we have started ML now. So 1 week is completed. So next 3 weeks. Next 3 weeks, we are going to work in the same way. First modeling, followed by evaluation, followed by model selection. Clear? Done? These three that is modeling, followed by evaluation, followed by model selection. These three of them are applicable for all the algorithms of supervised machine learning. For all the supervised machine learning, this is the same. For unsupervised machine learning, there is no output variable only. From where we'll compare? There we are going to identify the patterns only. We are not going to compare with the original data. Original data only, original output only, not there. So if I'm having Y test with me, I'll do the Y pred test versus Y test. If Y test only not there, what I have to do? Is that clear? So for all the unsupervised machine learning algorithms, we are going to apply the same logic of this one. Done, guys? Next, checklist number 4, linear regression. For linear regression, we are going to do these things. What are the assumptions? Miss, first assumption, we have to check whether the errors are linear. The error should form the linear. Okay, whatever the errors are there, they should be in the linear. That is the checklist number 1. Checklist number 2, second assumption. Second assumption is normality of errors. The error should form the normal distribution. Whether you are going to check skewness or whether you are going to make using the histogram, that is your choice, but error should form the normal distribution. Errors should have the normal distribution. And errors should have the equal variance. All the errors should have the equal variance. This is the third one. Okay. If it is satisfying all the assumptions, then it is a good model. If it is missing one assumption also, it is a bad model. Now the question comes in your mind is first one. Sir, if train and test are not same, then what we have to do? If test and CV are not same, what we have to do? If both are same and it is not satisfying the business problem, then what we have to do? If assumptions failed, what we have to do? In every case, opposite. If everything satisfies, it is a good model. If one of them fails, miss, it is a bad model. Then if it is a bad model, what we have to do? That is the question. So let us see one by one. In the today's class, I'll show you if assumptions are failed. If assumptions fail, miss, what we have to do? In the tomorrow's class, I will take one more data set. There, if these both are not equal, then what we have to do? In one more class, I will show if these both are not equal, what we have to do. For each data set, I'll show different. Finally, you'll understand if this is the scenario, okay, we have to apply in this way. If this is the scenario, we have to apply in this way. Is that clear, guys? So let us see with respect to this equal variance of errors. The errors should be equal variance. And last one, we are having the variable significance. Every variable should be a significant, means whether we have to consider that variable or not. How we are going to decide means that particular variable p-value. We are going to see that p-value. If the p-value is less than 0.05, we have to consider that variable. If the variable having the p-value more than 0.05, we have to delete that variable. Simply, we have to delete it. Okay. Next, finally, once we have finalized everything, we are going to save the model and we are going to share. Is that clear? Now, final model, whatever the final model we are having, this is the final model. Now, from the final model, we have got the answer as sales is equal to 4064.8 plus 0.04972 into total spend. What is my business problem? They asked the relation. What is the relation between total advertising spend versus sales? So this is the relation. With what accuracy this relation is there? With what is the accuracy of this relation? With 75% accuracy. This relation is having with 75% accuracy. Okay. So I'm creating a relation between input versus output with 75% accuracy. How you told that 75% accuracy? Whatever the test accuracy is there, that is the accuracy. Here I have got the test R square. What is the test R square? Which is nothing but 74.5. So that is the accuracy. If it is a good model, miss, this is the accuracy which we are predicting. If it is a bad model, miss, simply delete. We are not going to use. Right? 100% is not possible. If the 100% data, perfect data is there, perfect answer is possible. For worst data, worst answer only possible. Right? It is not mandatory that in the real life we can get with 100% possibility. Okay. In the real life, we may get with respect to 60% to 70%. We can't get 100%. Okay. Unless the data is having perfect data division, then we can predict with 100% accuracy. Right? Now, here that says, whatever the says we are having, says is equal to 4064 plus 0.047216 into total spend. Now, from this, what we are going to understand, whatever the beta value is there, this is the beta value. What is this beta value will tell? Let us understand with a simple example. 1, 2, 3, 4, 5. X. Y is equal to 6, 7, 8, 9, 10. Okay, I'm having like this. Now, y is equal to x plus 5 is the equation. Okay, x plus 5 is the equation. I have identified the relation between these two and I have concluded y is equal to x plus 5 is the relation. Now, from this y is equal to x plus 5, y is equal to x means 1 into x plus 5. Here, nothing but beta 1 x plus beta naught. Now your beta 1 value, what is beta 1 value? Which is equal to 1. Beta naught value is equal to 5. So in this equation, beta 1 is equal to 1, beta naught is equal to 5. Now what is the meaning of this one means? If you, what is beta 1? What is the meaning of beta 1? Beta 1 meaning is it is a slope. What is meant by slope, guys? Slope is nothing but change in y divided by change in x. That is nothing but y2 minus y1 divided by x2 minus x1. That is called as slope. Now here, the slope, the beta 1 is equal to delta y by delta x. Now delta y is equal to beta 1 into delta x. Can I write like this? Now, if I change my x value with 1 unit, means the change in delta x is equal to 1. That is x2 minus x1 is equal to 1. Then what is the change in y? If x2 minus x1 is equal to 1, then what is the change in y? Which is equal to beta 1 only. Now, in this case, tell me for this example, whatever you have calculated for this, tell me what is the beta 1 value? For this example, what is the beta 1 value? 1. You are changing in the x variable. X, you are changing the x value from 3 to 4. What is the change in x here? What is the change in y? Is equal to 1. From where you got that one? Means beta 1 into beta 1 is equal to delta y by delta x. Your delta y is equal to beta 1 into delta x. If the delta x is equal to 1 means delta y is equal to your beta. Your delta y is equal to beta 1. That is nothing but to its slope. Your change in y is equal to its slope. For example, let us try with one more example, x and y. Now 1, 2, 3, 4, 5. Now here I'm trying instead of this one, I'm trying with 2x plus 5. So 2 1s are 2 plus 5, 7. 2 2s are 9 plus 5. Sorry, 2 2s are 4 plus 5 is 9, 11, 13, 15. Now for this data, the equation is this one. This is the equation. 2x plus 5 is the equation. Now, change in y is equal to, change in x is equal to 1 means how much change in y is there here? Which is equal to your beta 1 slope value. Got the point? So nothing but beta 1. Beta 1 is nothing but called as slope, or it is also called as coefficient in the machine learning, which is also called as coefficient in the machine learning. Beta 1 is equal to delta y by delta x. So your delta y is equal to beta 1 into delta x. For every change in unit of 1, it is equal to delta y with respect to slope. Right? Now here the same logic. Now I have got the beta 1 value is equal to 0.0472. Now I'm going to increase for every unit increase in the total spend. How much there will be increase in the sales? It is going to increase 0.049 units in the sales. Means for every $1,000 you add in the ads, you spend more, we can expect 49 more units will be sold. That is the meaning of this one. If you want, you can try. No need to buy hard. Just you can try. First, sales is equal to 4064.80 plus 0.049 into total spend. First, can you apply 5,000? If I am doing for 5,000, if my total spend is equal to 5,000, what is the answer, guys? Can anyone tell me? If my total spend is equal to 5,000, just open your calculator and tell me the answer. If the total spend is equal to 5,000, what is the answer? Huh? Say if the total spend is equal to 5,000, what is the sales? Sales is equal to 4,064.8 plus 0.049 into 5,000. 4,064.8 plus what is this? 0.049 into 5,000. 245. Okay, now if you add 245 here, what is the total? $0.049 into 5,000. 245 plus 4,064.8, which is 4,309.8. Now instead of this one, now what you do is just increase the sales by $1. The spend you increase by $1. Now tell me what is the change in the sales you have got? 4,064.8 will be as it is. It is not going to change. 0.049 into 5,001. Now what is this one? That is 4,064.8 plus what is this value is going to be? It is equal to 245.049. Obviously it will be 244.049. Same. 0.049 into 5,001. What is the answer? 245.049 only, right? So 245.049. If you miss, now tell me what is the difference you have observed here? Here there is 245. Here the every left side value is same only, na? What is the difference then you have observed? Only the changes in the second side. Left side intercept is not going to change. Intercept is not going to change. It is changing only here. In order to predict this value, it is changing only here. Now, what is the difference between these two, miss? What is the difference? 0.049 only. That is the difference between them. So, if you add $1 increase, miss, you will get 0.049 difference. $1,000 if you add, means if you take instead of 5,000, if you go with the 6,000, then what is the answer? Instead of 5,000, if you add $6,000, you have increased your X value to 1,000. Total spend you have increased it to $1,000. Then what is the expected value of this one, miss? Which is equal to 294. Instead of 245, you'll get 294. Just try. Open. Where is this calculator? So 0.049 into 6,000. 294. Now, how much is the difference between these two? 49 is the difference. I have written the same. For every $1,000, if you increase 49 more units, you'll get. Because intercept is not going to change. Intercept is not going to change whether here or here. Only the difference you'll observe only in the associated value, the quotient value only, the change you'll observe. So how we are going to interpret the quotients, miss? Based on this, we are going to interpret. Is that clear now? So now the question is, they're asking for $2 lakhs. What is the second question they asked? For $2 lakhs, if I invested $2 lakhs, what is the expected units of sales? So we are going to substitute in the equation, whatever the equation we have done. In this equation, we are going to substitute that value. What value? $2 lakh. In this equation, whatever the equation we have got, we are going to substitute in this equation $2 lakh. Now, after substituting $2 lakh in this, what is the answer we are going to get? That is 0.04927,216 into $2 lakh. Okay. Plus intercept. Intercept is 4,064.80257. 80257. And what is the expected value, miss? 13,919.23. So expected value is this one, 13,919. You are going for the total spend of $2,000 on the ads. How many units will be expected to be sold, miss? 13,919 units will be expected. How you are going to work like this? By using the model.predict on $2 lakh. You have to give the input as 2 lakhs. Then it will predict the answer for 2 lakhs. So if I want to execute this particular cell, first I have to execute all the cells because I have started the kernel right away, right? Let us clear all the outputs and re-execute everything. $13,919. Is that clear? The answer is clear. 13,919. In this way, we are going to predict. Next, how it is working, this one, how you got this answer, miss? Just it is substituting here $2 lakhs. In the equation, it is substituting the $2 lakhs. Clear, guys? So in this way, we are going to work. This is the first one, the first project where we have implemented all the steps. Step 1, step 2, step 3, step 4, step 5, and step 6. Everything we have implemented. Now let us try with the second project, project number 2. Project number 1 is completed by applying. This is called as simple projects. Whatever we are working, it is a simple project. For the same data, if you apply all the algorithms, if I apply algorithms, every algorithm, if you apply, then it is called as capstone project. That is called as capstone project. If you are not applying every algorithm, just you are applying only one algorithm, it is a normal project, general project. Right? Now, project number 2. Let us start with the project number 2. I have shown you how to calculate, but we have to calculate in the real life either RMSE only RMSE. We should not go with MAE. We should not go with MSE. Only RMSE. Yes, that this one is applicable only within the given range. Whatever the range of values is there, that is the what is the minimum total spend? Minimum total spend is 11,700 to 43,600. For example, in the same logic, for the same data, for example, here, this is one of the most important question. If I assume that I'm spending a total spend of $1, only $1 I'm spending, means I will expect minimum 4,000 units I'll get. For $1 say, for $1 spend, can I get the sales of 4,064 units? As per this, if I substitute in the formula, whatever the value I'm substituting in the total spend, I'll get with respect to now. I'm doing the spend only $1, just one, not even 1,000, one single dollar, $1 I'm spending. So what is the expected units of sales for $1? Means sales is equal to 4,064.80 plus 0.0492 into 1. So for $1, let us try here $1 by keeping only just $1. 4,000 units I'm getting, which is a wrong answer. This is not applicable with that. Now it is only applicable for the data between this to this. So what is the data it is applicable means between a data set of 11,700 to 4,33,600. Between the range of 11,700 to 4,33,600 only, this logic is applied. Whatever you have calculated beta naught plus beta 1 x. If it is more than that also, it is not applicable. Less than that also, it is not applicable. Right? That is the limitation of linear regression. One of the most important interview question. Actually, I taught this one to ask in the test accuracy. I want to test the test accuracy now. Right? So that is the reason I have not told this one. So here the question is, as one of the student has asked that question, sir, what is the range of x values we can substitute? Anything, infinite value we can substitute? Miss, we can't substitute. Okay. So we are identifying the relation. This concept is called as interpolation. If you want to come out of that, sorry, not within the range, I want to apply for this one and I want to apply out of that, then we have to go with the extrapolation. Interpolation means within the data only we can apply the model. If you want to come out of that one and if you want to apply, means if you want to try with $1 also, what would be the exact answer means that we have to do with the different algorithms. In linear regression can be applicable only for interpolation data. That is one of the limitation of the linear regression. This is called as limitation, and which is also called as disadvantage of linear regression. Linear regression cannot be fitted for more than this data. That is one of the disadvantage of linear regression. Extrapolation cannot be done on the linear regression. Extrapolation you have to do means we have to try with the different algorithms. Linear regression is not suited for the extrapolation. Is that clear, guys? Next, finally, once everything was saved, now everything was completed, saving, everything was done up to here. Okay, with the $2 lakhs I have done, I have predicted for $2 lakhs and everything and completed. With this, everything was completed and the business problem requirement also completed. The business problem requirement is first they asked to identify the relation. Yes, I identify the relation. Second one is they asked for $2 lakhs. What is the expected answer? So identify the relation, which is a good model, neither overfitted, neither underfitted. And its cross validation score also equal to your test. It is a good model. It is a good model, not a bad model. It is a good model with 75% accuracy. It is a good model which is having with 75% accuracy. Okay. Now I can even conclude here itself. I can conclude here itself. When I have seen the test R square here itself, my process will be completed. But we should not stop here, because whether our model is a good one or bad one, first we have to see that one. We should not stop here. Okay, after seeing the test accuracy, we should not stop. We have to compare, we have to see whether our model is a good one or a bad one. Generally, everyone, most of the people, they will do the evaluation up to here only, test accuracy, and they'll stop the modeling. Means they'll stop the algorithm, but which is a wrong one. They have to do the model selection also. They have to check whether our model is a good one or a bad one. If it is a bad one, for example, you are having a overfitting problem where train test accuracy have got 100%. Test accuracy have got 100%. Train accuracy have got 80%. But you have not checked. You have not even checked. You have got test accuracy 100%. Directly you are submitting this one. Then when they apply on the new data, then more bugs they'll get. In the real life, once this particular model they have deployed, they'll get the more bugs, means more errors. If you give a wrong model, automatically they'll generate the more bad answers. So whether it is a good model or a bad model, means we have to do the cross validate. We have to try for different data. Again, then whether if it is a good model only, we have to share. Sir, for example, test accuracy is 100, sir. Train accuracy 80, sir. Assume that this is the thing. It is a underfitted model. It is not a good model. It is an underfitted model because test accuracy is greater than the train one. So it is an underfitted model. This is called as underfitted model. Should I submit this one? No, you should not submit. Simply, then what I have to do? Shift delete. You have to delete permanently. This model is not applicable for this data set. You have to delete. You should not consider this model. Sir, test accuracy 100%, sir. Worst, sir. Though it is a 100% also, worst only. That model is a worst. You should not focus single value. You should focus with both the values. Sir, test accuracy 100 and train accuracy 80. This is the one. Test accuracy, I have got 80. Train accuracy 80. Now, out of these two now. Anyways, train accuracy in the both the cases same. In the both the cases, train accuracy is same. But test accuracy, at least I'm having 100 now. Still, it is a worst only, sir. This logic can be applied only between the good models, not between the worst model versus good model. Worst model means worst only. You can't apply that worst logic for the worst model. Okay, this is called as simply a bad model. Concluded as bad model. We can't compare with anything also. Bad model. Blindly, it is a bad model. Now, if it is a bad model, what we have to do? Either you have to do the betterization. How we can do the betterization? That is further. We'll discuss in the further class. Advance. Slowly we'll move on to that. If it is a bad model, then what we have to do? We have to do the betterization. For example, in this class, one student is not focusing in the class. What we'll do? One person is slightly sleeping. Again, he is seeing the board. What we'll do? We will scold them, but indirectly. That person and I only will understand. Right? To whom I am saying, that person will understand, I will also understand. Matter will be completed. This is one way. Directly pointing at him, directly we can scold. This is one way. Directly showing at one person's face, Ray, third bench, first student, you are sleeping, Ra. Like this, directly pointing that person and scolding is one way. Second way is indirectly. Finally, ultimate is scolding, common. That is common. Right? Similarly, here also the same. We are going to get the better model, but for getting the better model, different options are there. We'll try all the options. Right? I'll show you each and every option. Now coming to this, once the model is a good finalized, everything is finalized, then how we are going to share it to the client or to others? Means we are going to save the model. How we have to save the model? Means from joblib. From joblib, import the dump. How to save a model? Means from joblib, import the dump. Now dump model You are going to save the model. Which model you want to save? What is the name of that model? For example, I want to save this model. What is the name of this model? Here some name is there now. Whether it is a model 1 or something, some name will be there, right? That model, whatever the name you have given here, this name you have to take here. Model, comma, and in what way you want to save that one in your laptop or in your desktop, in your hard disk, how you want to save, miss? Sales underscore model. In this way, I want to save. This model I want to save in my laptop as sales underscore model dot joblib. Once you click on this, now it is going to be saved. It will be saved. Where it is going to be saved? In your working directory. The model will be saved in the working directory. The model will be saved in the working directory. The model will be saved in the working directory. Yes. How it is going to save as? Sales underscore model dot joblib file. It is going to be saved like this. In your working directory, it is going to be saved like this. Which one? Which one will be saved? This equation. Whatever the equation is there, this equation will be saved in that. Now, once this equation is saved, everything is completed. Okay, everything is completed. With this, the Jupyter Notebook completion is over. Now, if you open your working directory, this is my working directory, where this is the data set, which this is the Jupyter Notebook which I am working. Okay. Now, for this, if you see here in my working directory, sales underscore model dot joblib just now created 15/05/2023 at 7:12, means just now. Now, once this is created, close the Jupyter Notebook. Close it. Your work is completed. With this, the data scientist work is completed. Close. Now, after closing this one, now what you are going to do is just you are going to share this joblib file to your client or deployment team or software engineers, whatever is there. To them, you are going to share only this file. This is the final file which you have to share. Now, what they are going to do is, see, I'm going to open a new Python file, where in this new Python file, I'm going to use from joblib. From joblib, I'm going to import load function. This is the one which I'm going to import. And once I'm going to load, what I'm going to load, whatever the model you have shared me. What is the name you have? What is the file you have shared? Sales underscore model dot joblib. This one I'm going to load here. Okay, this file I'm going to load here. And whatever I'm going to load, I'm going to save in a name, some name. What is the name I'm going to keep is some name called as S model, S underscore model, something you can save it. Okay, now yes, pickling and unpickling both are same. Similar, either you can save as a pickle file or you can save as a joblib file. Okay, both inverted commas are different. Okay, once you have saved the model, now using your model, yes, underscore model, whatever the model you have saved, using this model, predict on $2 lakhs. They are going to do like this, $2 lakhs. They'll check. Okay, 13.919 is the answer. Others will check in this way. They will not see entire from starting to ending. What is the data cleaning you have applied? What is the data wrangling you have applied? They're not going to check like this. Just they'll see the as per the requirement. So simply they will load the model and they'll predict on the whatever the value want. Miss, tomorrow, if they increase their budget to $2,10,000, what is the expected sales, miss? 14,411. 14,411. That we have to send the mail. In the mail, sir, as per your business problem requirement, we are sharing this is our final model, which gives the accuracy of 74%. We'll send in the mail. Now what they are going to do here, actually here I have applied on a single data now. Basically what they will do is they will also have some data with them. Some total spend versus sales. So here if you observe, for example, let us take like this. Let us take an example. Here, how many records I have worked on this? Total, initially the data set is of 200 records. The shape, if you see the shape of the data, it is 200 records. And I have got 74% accuracy. Now, in this data cleaning, I have not treated the outliers. I have not converted the skew distribution to normal distribution. Nothing I have done. Only missing values encoding. Only these two only I have done. Now, your assignment. I'm going to share you the assignment. Now, your assignment is within the simple linear regression, your target to increase more than 74.5. Whatever you want, you do. But within the simple linear regression only. You should not come out of the simple linear regression. Okay, within the simple linear regression, your target is you have to get the test accuracy more than 74.75, which is a good model. Neither overfitted or underfitted models, not only good models. Okay, this is the target I have given to you. Okay, now you are going to try with all the options. What are the options you are familiar with? Maybe by removing the outliers, the accuracy might increase. You might check like that. So you are going to try. After you are trying and you have got 79.4. Assume you have got this much something. Or you have got, I told more than 74.5, anything is okay. Assume you have got 75.2 only. 75.2 also is more than 74.5, right? Let us assume 75.2 you have got. Now you will say that, sir, I have got 75.2. Then simply I have to believe you. Whether I have to believe you? Sir, I'm going to share the Jupyter notebook, sir. You please check. You will say like this. I'm not going to see the Jupyter notebook. Then what I'm going to do is, here I have shared you 200 records now, but with me an additional 20 records are there. Actually, this data set is of 220 records. I have removed 20 records. I have kept separately with me. Now, the students are going to share me this job.lib file. After sharing this job.lib file, now predict whatever the predict on my data. These 20 records are there, right? First, I will load these 20 records. These 20 records, I'm going to load in a data frame number 1. df1 is equal to these 20 records, pd.read_csv. And I'm going to load the test.csv, which is used for my testing purpose. Assignment.csv instead of test.csv. Don't get confused with again that one. So let us try with a different new word called as assignment.csv. I'm having one more CSV file where it consists of 20 records. In this CSV file, what is there means 20 values of total spend versus sales is there. 20 values are there. Now, whatever the model you are going to share it to me, first what I'm going to do, I'm going to import the pandas and I'm going to load this CSV file. 20 records I'll get. In that 20 records, your model has predicted on this total spend. I'm going to use your model, that is df1. What are the df1? df1 of total spend. df1 of total spend. Okay, I'm going to give this input as like this. Now automatically it is going to predict the how many values it is going to predict. 20 values it is going to predict. Now these 20 values I'm going to cross verify with my 20 values, original answers. This is the predicted values. So pred, this I'm storing in the pred. And when compared to this one, the predicted values are there, original values are there. Now I'm going to cross verify how much is the accuracy or how much is the RMS. And based on that, I'm going to conclude whether it is really having 75.2 or not. For example, for these 20 values, assume for these 20 values, I have got only 70. I have got 70 only, not 75.2. 70 only I have got. Immediately, I'm going to say to you, hey, you have told that 75%, but I'm getting only 70. No, sir, 100%, sir, I have done, sir. 75 I have got, sir. You say like this. No, Amma, I have checked, I'm getting only 70. Sir, please share me your data set, sir. Maybe some problem in your data set. Somewhere you have made the mistake. You only have made the mistake. Please share that. I will see. What's wrong in that? I will see. These things we can ask each other. You will ask me and I will also discuss with you. But in the real life, we can't ask the client to share your data. He will not share the data. Simply, he will say that it is not satisfying my requirement. He will conclude in that way. Simply, he will say that it is not satisfying the requirement. If it is satisfying the requirement, means he'll release the money. If it is not satisfying the requirement, he'll not release the money. In that, so here, whatever the data pre-processing you have done, in your data set, whatever the type of data pre-processing you have done, you have to save that data pre-processing also. So for unknown data, if you want to predict, means first it has to be done data pre-processing, then we have to apply the model.predict on that. Directly on the direct data, we can't predict. First, we have unknown data should be done the data pre-processing, then we can apply the model.predict. On that clean data only, we can apply the model.predict. For example, the original data is consisting of male, female, something like this, assume. And we have done the encoding. Now, if you use the model.predict on the male, miss, it will throw the error. So in the unknown data also, if you're having male or female, first it has to be converted. For unknown data also, we have to do the same data pre-processing, whatever we have done, same data pre-processing should be applied. Then only we can apply on the model. Right? Example, I'm saying for this is the simplest of all the data sets. This is the simple one where there is no missing values. There is no encoding. Nothing is there. But in the future data, everything will be there now in the next project. So for example, let us take like this. See, I have applied, this is the data set where this data set is having, this is the Y, X1, X2, X3, X4, X5, X6. And I want to identify the relation between the input versus output. Now, first I'm going to do the modeling. And once the entire modeling is completed, data pre-processing, in the data pre-processing, I have removed some of the columns. Some of them I have done the replace. Some of them I have dropped the variable. And after that, train test split, after that modeling and evaluation. And once the modeling and evaluation is done, now my final model is ready and I want to predict on the new data. This is the new data. For a new data of age of 31, gender of female, BMI, children, and this one, what is the expected value? Directly, I'm not going to use this input data, model.predict on the input data, I'm not going to give. Whatever the model is there, model.predict on the transform data. I'm going to give this transform data here. And once I give the transform data, I'm going to get the expected answer. Right? Directly, we should not give the original input data. Model.predict on input data, we should not do. First, we have to transform. Data pre-processing has to be done. And whatever the transform data is there, this transform data you have to give here. The input should be transform data. After data pre-processing, whatever the transformed data is there, this should be the input data. Then for the input data, it is going to predict the answer. Okay. Example. If you want to see the answer, let us do this one. Restart and run all. Okay, here, what is the spelling? Okay, done. Now here, the model, what is the model name? Finally, the best model is, the name is lasso_best. This is the data. For this data, if I apply lasso underscore best, directly whatever the data is there, lasso underscore best with respect to predict on the input data. If I give directly the input data, what happens? It is going to throw the error. Now the same thing, first I'm going to do the data pre-processing. After doing the data pre-processing, transform data. Now if I apply the lasso underscore best dot predict on the transform data, then it is giving the answer. Directly we can't give the input data. First we have to do the data pre-processing, then we have to give the input data, then it will predict. In our case, in this example, there is no transformations, no data pre-processing was done now. No missing values treated, no outliers, no encoding, nothing is done. So this is a simple example. For this one, we have to do the transformations. Is that clear, guys? Now, slowly, one by one, you'll understand. As of now, don't think too much of the future one, what we are going to do in that case, what happens, in that case, what happens. Like that, everything we are going to see for multiple cases. 20 projects means 20 different cases. Everything will not be the same. In this situation, what we are going to do, in this situation, what we are going to do, like that, we are going to see 20 different projects. Is that clear, guys? So that variance table, please explain. Sir, that variance table, which variance table? Where you are having the variance table? Describe function, this one. This is the table. This table you are asking, Abhishek? No, in which p-value? Okay, p-value, got it. Okay, here. So here we forget about the intercept. You don't need to focus on the intercept. Only we have to focus on the variables. So here I'm having in this particular simple linear regression, only one input variable will be there. But for the others, like for example, let us take earlier the same example. In this, what is the number of input variables? In this example, what is the number of input variables? Means 1, 2, 3, 4, 5, 6. 6 input variables and 1 output variable. This is the output variable. Okay. How to identify the output variable means based on the business problem. First understand what is business problem so that you'll understand what is the output variable. Which one they are asking to predict, that is the output variable. Okay. Whatever they're asking to predict, that is the output variable. So I want to predict the expenses means this is the output variable. So here I'm having one output variable and 6 input variables. Now I'm having here total 6 values will be there. X1, X2, X3, X4, X5 and X6. For each of them, the p-value will be there. So out of the p-value, whichever the p-value is greater than 0.05, that particular variable we have to remove. That particular variable is not having any importance. How, sir? How you are deciding that one? That we'll see in the tomorrow's class. So how we have decided that one means tomorrow's class is multiple linear regression, where we are having the multiple variables. So in this multiple variables, see, here I'm having 3 variables. First variable, second variable, third variable. Out of 3 variables, first variable is satisfying, second variable is satisfying, but third variable is more than 0.05. It is not satisfying. So tomorrow's, what is the project we are going to work means? Today we have worked with respect to simple linear regression, only the relation between single variable versus single variable. That is total spend versus sales. We have worked on the total spend versus sales. Tomorrow's project is individually we are going to work with respect to TV, radio, newspaper, how each of them is going to impact. That is, what is the relation between each advertising channel and the sales. That is TV, radio, newspaper along with the sales. Now 3 input variables and 1 output variable. Okay. Now Within the 3 input variables, what is the first input variable? What is the first input variable? TV. TV is a good one or a bad one means good one. Radio is the second one. Whether it is a good or bad means good. Newspaper, whether it is a good or bad means bad. It is not working. So P value is greater than 0.05. We have to remove the newspaper. Why we have to remove means newspaper is not having the linear regression. It is not applying the linear regression between newspaper versus sales. How you know that one, sir? Very simple. By using this plot, we can conclude also. So here you can see here for TV, whatever the TV is there, X of 0 means TV. TV versus output variable. You are having a linear line. Okay. Radio versus sales. You are having a linear line. But newspaper versus sales, almost horizontal line. There is no linear line. For linear regression is not applicable for the X of 2. What is X of 2 means? Nothing but newspaper. X of 0 means TV. X of 1 means radio. How X of 0 is TV means X is equal to, I'm going to consider the TV, radio, newspaper. These 3 columns comes under X. Y variable is sales variable. Automatically, what is the index number of the first column? 0. Second column is 1. Third column is this one. So TV is good one, radio is a good one. Both of them are forming the linear regression, but whereas this one is not forming the linear regression. Since it is not participating in the linear regression, for linear regression, we have to remove the newspaper. In that way, we are going to remove. What is this plots? In the tomorrow's class, I'll explain. Simply as of now, you can conclude that any p-value greater than 0.05 of a particular variable, that variable we have to drop. Simple conclusion. Detailedly, we'll discuss in the tomorrow's class. What is the reason behind that, how it is working, and what is meant by partial differentiation. Everything we'll see in the tomorrow's class. Okay. Yes. Next, Sunil is asking the random state. Sir, why we have considered the random state of the particular number? How to select the best random state? Just how to select a best random state means, what we are going to do, we are going to try for different random states for I in range of 0 to 1000. 0 to 1000 and do the train test split. Train test split with x comma y comma random state is equal to I. For each range means first it will try with the 0. It is going to split random state of 0. It is going to split and identify the train R square, test R square separately. First, after that I is equal to 1, calculate the train and test. After that I is equal to 2, calculate the train and test. After that I is equal to 3, train and test. After identifying for everything, identify which is having the maximum. That random state you lock. How to apply this for loop? If you want, I will show you in the tomorrow's class. How to lock the random state number. Tomorrow we are going to see. So first in the tomorrow's class, first I'll show you how to fix the random state. First I'll show you this one. How to fix the random state number. This number, how to lock. Once it is locked, then we'll apply all the different models on the data. If it is locked, then we can apply. If it is not locked, how we can apply? First, data should be locked. So data should be locked means how we are going to lock that I'm going to show you in the tomorrow's class. Is that clear, guys? Tomorrow I'll show you and just I'll apply the for loop only. I'll try for different random state numbers and out of that which is having the best one that I'm going to select. Exact code I'll show you.